Part 5. Proofs that are not valid. In order for a proof to be valid, the argument used to support the generalizations or conclusions must also be valid. All you need is a single error in reasoning to result in an invalid conclusion in deductive reasoning. The purpose for writing a proof is so that others can read and understand it. Make sure it is clear. Have someone else read it for clarification. That's a good tool to use. Proofs that include an argument that is based on a false statement are invalid. Even if a valid argument is used, if one or more of the starting premises is not true, the conclusion cannot be true. Example: Jane claims that she has proved that negative 5 equals 5. Jane's proof: I assume that negative 5 equals 5. Then I squared both sides, and I got a true statement, 25 equals 25. That means my assumption must be correct. Where's the error in Jane's proof? Well, Jane started with an invalid statement. Negative 5 clearly does not equal 5, because if you have lost $5 and you've gained $5, that's a big difference. So, the error in Jane's proof then is her assumption, and using her assumption, in her proof. Because you can't use something that's not true to prove something to be true. So using negative 5 equals 5 in proof. What Jane used was something called a circular argument. Circular reasoning uses the conclusion that is to be proved as part of the argument. In other words, you assume that you're supposed to be proving is true and use the statement as part of your proof. It's like arguing in a circle and is not a valid form of reasoning. The following statements and arguments are examples of circular reasoning. You should exercise because you should exercise. If speeding were not illegal, then it would not be prohibited by the law. But speeding is prohibited by the law. That's what makes it illegal. Oh boy. Let's see what else we got here. Another example. Wayne is trying to prove the following number trick. Choose any number. Add 3, double it, add 4, divide by 2, take away the number you started with. Each time Wayne tries the trick, he ends up with 5. His proof, however, does not give the same result. So let's take a look at what Wayne did. He chose a number, he called it n, because it could be any number. N plus 3, good. Doubled it, 2n plus 6, added 4, 6 and 4 makes 10, because we can't add the 4 to the 2n, because they're not like terms. Divide by 2, and take away the number you started with. So 2n take away n gives me n plus 5. So that's not 5. Try the number trick yourself. Does it work? So go ahead and pause the video, pick a number, and see if you can get it to work. You should be getting 5 as an answer. So where's the error in Wayne's proof? If you want to pause again the video to see if you can find out where he made the mistake, go for it. So let's start at the top. Choose any number. We chose n. Perfect. We added 3. n plus 3, dandy. We doubled it. 2 times n, 2 times 3. Yep, that's good. Added 4. 6 plus 4 is 10, so that's good. Divide by 2. Now remember, when you divide by 2, that means you divide both terms by 2. So 2n divided by 2 plus 10 divided by 2. So 2n divided by 2 leaves n, and 10 divided by 2 leaves 5. Then take away the number you started with. So minus n, the n's cancel, and I'm left with 5, as Wayne said. So he forgot to divide the 2n by 2. Errors in logic can also lead to invalid conclusions. Take a look at the following cartoon. Penguins are black and white. Some old TV shows are black and white. Therefore, some penguins are old TV shows. Logic. Another thing that penguins aren't very good at. It is true that penguins are black and white. It is also true that some old television shows are black and white. To deduce the two statements that penguins are old TV shows is not logical. There is no connection between the statements. When there is an error in logic, an invalid argument, and no reliable conclusion can be made regardless of whether the premises are true. Let's look at these examples. Decide whether this argument is valid or invalid. Justify your response. Val lives in Sylvan Lake. All people who live in Sylvan Lake like to swim. Therefore, Val likes to swim. Seems reasonable? You decide. Pause the video, make a decision, and justify it. Okay, I think that this is invalid. And the reason it is invalid is because we make an assumption that all people in Sylvan Lake like to swim. So this is a not valid assumption. I can tell you this because I used to live in Sylvan Lake and I did not like to swim. So therefore, this cannot be true. Okay? Part B. A pound of Julia's Special Blend coffee costs more than $22.75 per pound. John didn't buy Julia's Special Blend when he purchased coffee. Therefore, John didn't spend more than $22.75 per pound. Again, pause the video, see what you think, turn it back on, and I'll tell you what I think. Now, just because John didn't buy Julia's Special Blend doesn't mean he couldn't have bought another expensive coffee and paid more than $22.75. Okay, so I think, again, that this is invalid. It's like the penguin question, okay? Just because he didn't buy it, right? Just because the penguin's black and white doesn't mean that he's a TV show, okay? So, he could have bought a different, more expensive coffee, like Kona. Apparently that's the best coffee you can buy. All right, give this some practice on page 42, questions 1, 3, and 6.